Hello everyone, let's do the 2.1 CYU. Our C1 question asks, how can you use slopes to prove that the derivative of a constant is 0? To prove that the derivative of a constant function is 0 using slopes, we can use the first principle definition of derivative, the difference quotient. We know that the equation of constant function is f of x equals c, where there is no x variable but just a constant. The derivative of f of x at any point x is defined as f prime x equals limit h approaching 0 f of x plus h minus f of x over h. Since f of x equals c for all x, we substitute f of x plus h equals 0 and f of x equals c as well. Since our function is a constant, that means f of x plus h is also just c, because no matter what x you pick, the function always gives you the same number. Then the difference quotient simplifies to f prime x equals limit at h approaching 0 divided by h. Since the expression is always 0, taking the limit as h to 0 gives f prime x equals 0. Here's an example with numbers where f of x equals 3. After substituting and simplifying, we get the same answer, which is 0, when you find the derivative of a constant number. We can interpret this through a graph. The graph of f of x equals 3 is a horizontal line at y equals 3. The slope of the horizontal line is always 0 because there is no rise, meaning that the rate of change at any point is 0. This confirms that the derivative of constant function is always 0. Our next question, sheet 3, asks, why can we extend the sum and difference rules to 3 or more functions? Because differentiation is a linear operation. Linearity operation aligns with the superposition principle, where the net result of the system equals the sum of each subunit within the system. This means that when you differentiate the sum or difference of functions, you can just differentiate each function separately and combine the results. The same rule applies whether you have two functions or many. The basic sum rule for two functions tells you the derivative of f of x equals g of x plus h of x equals the sum of derivative of individual functions, which is derivative of g of x plus derivative of h of x, which will result in f prime x equals g prime x plus h prime x. The same thing happens with difference rule, but subtraction happens instead of addition. Now these rules are extended to more than two functions because differentiation works the same way for any number of functions added or subtracted. Example with 3 functions. Let's say you have a function with 3 terms, which is 2x squared plus 5x minus 8. We want to differentiate x. Using the sum and difference rules, you differentiate each term separately. First, the derivative of 2x squared, which is 4x, and we got this from using the power rule. And the second, the derivative of 5x, which is 5. And the third is the derivative of negative 8, which is 0 because it's constant. So applying the sum and the different rules to these 3 terms, we got f prime x equals 4x plus 5 minus 0, which would give us f prime x equals 4x plus 5. And why this works all time? Because we can extend the sum or difference function of function to any number of functions as long as they added or subtracted due to the application of same rules and linearity operation. Whether you have 2 terms or 10 terms, you can simply differentiate each terms independently and then add or subtract the results. That's all for today. Thank you so much.